Hello and welcome to this Kubla Cube tutorial where we'll walk through a typical commercial project using CAD data. If you prefer working with PDFs, a separate video covers that process, so check out the link in the description. Okay, so it's a good idea to begin by opening the CAD file to assess its setup. This step is optional, but for those using a CAD application, it's highly recommended. So you can check that the existing and proposed contours have the correct Z elevations. So this one, for example, is 100 and it's set to 100 in the Z value. And then we can do the same for the existing. So this one is 60 and we can see that that one has a Z value of 60 also. We also have these hatched areas for the adjustments from finish level to subgrade level. Don't worry if you have any contours that are missing elevations, you can add those either in your CAD file or in Kubla Cube. We have the wonderful Set Multiple Elevations tool to make that more efficient. Okay, so ensure also that the layers are organised with existing contours on one layer and proposed contours on another layer. The proper setup of your file just makes the import process much smoother. Okay, so start a new project in Kubla Cube by going to the Plans menu and then Add from CAD file. You can then browse and select the CAD file that you want to import. Note that CAD files are unitless, so Kubla Cube will attempt to guess the units based on your file settings. So it's worth double checking that the units and scale are correct by using the measure tool. So you can find a known length and then hold down the M key and check that that is correct, and we can see that yes, that looks about right. It's 35 feet, so we know that it's in feet and it's approximately the right value. So with CAD we don't have to do anything much more than that, and we just click OK and we can start importing our data. So to generate the existing topography, we need to import these existing contour lines into a feature surface by clicking the Add and then Feature Surface and selecting the Contours tab. Then we want to choose the option to Add from File and locate the site plan that we've added already. There is the option to browse and find another plan if you have another data file. Okay, so this is now a good time to go over the CAD Entity Importer, so this window here, and how it works. So this type of importer is used for both PDF and CAD files, and it's really worth mastering. In CAD there's a command called Select Matching, which when you select an entity, it will select other entities that have the same characteristics. So we've implemented something similar here. You set a filter on a small sample, so click New Filter, and find a sample of existing contours, and the system will then find all entities that match those characteristics based on that filter's attributes. So here we have the different filter types. So there's entity types, layers, colours, line weights and line types. So you can refine the selection. So if it selects, for example, 2 colours and you only want to use one of those, you can uncheck those, and the same with the other options. When it comes to contours, you usually want to select either a single filter, or maybe you might need 2 if you have major and minor contours. So sometimes major contours have a different line thickness, so they might not be selected with the same filter as minor contours. And in such cases, it's important to use 2 separate filters. Okay, so moving on to some of the other options, there's this option here to set 0 Z values to not set. If you remember from earlier when I was talking about the CAD file, sometimes contours aren't set or set to 0. So this setting allows the program to interpret them as not set, which can be advantageous later in the process, particularly with contours and break lines. We also have this cropping option here. So if you don't want to import the entire data set, you can crop to a specific region. If you have already defined a boundary, you can crop to that boundary, and if not, you can trace and crop a specific area, like so. However, in this case, we want the whole data set just to give a cleaner finish. So I'll just cancel that and clear the crop. And then we have these last two options. So the fixed line gaps feature is useful if you're dealing with dashed lines that don't automatically join. In this case, the program has detected and joined them correctly, since they are CAD lines with a dash style, rather than individual segments. But if they hadn't been joined, you could use the fixed line gaps to resolve that. There's also this option to remove short lines. So if there are small lines that you don't want in your set, you can just use the slider to remove those. So that covers everything for now. We'll just move on to simplifying the lines. So click the Simplify button to use the Geometry Simplification slider to reduce the number of points. So simplifying by about 0.5 feet can significantly speed up calculations without losing too much detail. So you can zoom in to check the impact of the simplification on the contours. So you can see that the bright white line is the original line and the grey line is your new simplified line. So I'm happy with the changes that have been made, but it may be that you want to adjust that, so you can just change the tolerance as required. And I'll click OK. Once you're satisfied with the contours, you can define the surface extent by creating an outline. So click on the Outlines tab, and then this time I'm going to click the pencil because I want to add an automatic outline. So an automatic outline shrink wraps around the imported contours. You can always import from your CAD file if you have an outline already, and you can see that that's come in, and this orange line is the new outline. And we'll click OK to apply and then view the feature surface in the model view. So you can switch it to the 3D view to inspect the surface. And this is looking good. But you can look out for any unexpected high or low points or any errors in your data. And to make it more visible, you can use the vertical exaggeration tool, which enhances the train's vertical scale. But here everything looks correct, so we can move on to the next phase. Okay, so in the next phase, I'm going to do a topsoil strip of the site by clicking on the Proposed One tab. And then we can right click to rename that topsoil strip. So the topsoil strip must be in its own phase, and you can watch one of our other videos on topsoil stripping for more details. So we use the reduce element to remove the top 6 inches. Draw the area by using your eye, like so, or you can define it by importing an outline from your CAD file. And then OK. And then automatically we have a depth set of 1 foot, so we can change that to 0.5 feet. Okay, and then we can check the 3D view to ensure the strip has been applied correctly. Okay, and that's it for the topsoil strip calculation, and you can see the volumes of cut here on the left. I'm just going to change the colour of the ground just so that we can see the site plan more clearly. So we can change the ground levels. One that is quite nice to view it is the ice. Click OK. And there we go. So for the bulk earthwork calculations, we create a new phase, and we can rename that one Bulk Earthworks. So first, I'll define the finish levels by creating a feature surface and extracting the proposed contours using a new filter. Just zoom in to that contour, and if we have any contours that have an incorrect elevation, we can always go in and adjust those at another time. What we can do is, we've got a bit of pollution here, so I'll just use the remove short lines to get rid of those, so they're now gone, and click finish. And we can do a little simplify. There we go. And then we have our contours listed down the side here. And then next we'll define the surface extent with an outline. So outlines must be a closed polyline. So if the outline isn't closed or it doesn't import properly, we have got a workaround, which is to import it as a break line. And then we can copy and paste it from the break line tab to the outlines tab. So at the moment we can see that this line has kind of multiple elevations along it, which we don't require. So what we can do is, as an alternative, we can set this as a match line to align it to the ground levels. So by changing the outline type to use ground levels. There we are. And we can click OK. Okay, so this error message indicates that one contour is much higher than the average of the others. So it's likely due to a typo or another issue. So for example, one contour is 146, while the average is 70.85. So to fix this, we click cancel and go to the contours, and we've got this option to sort down the bottom here. So we can sort by descending. Okay, and then we'll just delete one of them. We can check where it is by going to the selection, and it's this, and it looks like it's just there, an error. So you can delete it, or you can change it to the correct elevation down the bottom here. So I'll just delete that one as well. And okay. Once you're happy with all the corrections, then that warning will disappear. This is just saying that the contour lines come close to the ground level outline, which is fine. And with amber warnings, you don't have to make the change. It will recalculate the surface. All fine. So we'll click OK. And zoom out so we can see everything. Okay, and there you have it. We can just check the 3D. And that looks great. The only other thing we can do now is to add break lines along these edges to create nice clean lines. Break lines are crucial for defining sharp changes in elevation, such as retaining walls and road edges. So you can import them under the Breaks tab. So just click Edit on the feature surface. And there's the option to either trace them off the site plan, or we can import them from the CAD file. Okay, so breaks, and then this time I'll add them from the CAD file. In my file, the break lines are these pink lines here. So I've got one here, and then another one should be down here. Yeah, so you can see those. That's great. So with these break lines, you'll see that this one has got the elevation set, and then these ones have come in as not set. Okay, so this step just refines the finished topography and enhances the accuracy of the proposed model. And we can see these lines here have just made that a bit cleaner. Okay, so I'll just rename this element to finished floor levels. So we just double click there and type in finished floor levels FFL, and then enter. To finalise the project estimation, you'll need to use the reduce element to adjust to the subgrade level. For example, if your plan includes specific building footprints or other surfaces, use the reduce element to define these areas. You can see on this plan we have the building set to 1 adjustment, and then we've got a B surface and gravel. So I'll add a reduce element. And since we're importing from CAD and not tracing, we can just press escape or the cross first, and then select the add from file option. Set a new filter, and this time we'll use the hatch as our filter rather than an outline. And there you can see the buildings. Click finish and OK. And then we set the reduction depth according to your project specification, so such as 12 inches or 1 foot, which is the default here. And then we add each of the areas of adjustment in a new reduce element. And then we ensure that these are named clearly. So this one we can rename to adjust for building surface. And then add another one. Click escape. There we are. So it's good to pay attention to the order of these elements in the list. If they intersect, the lower one in the list will override the higher ones. So this is particularly useful for complex sites where different surfaces overlap, but in this case it has what is known as a punch out, so it's an outline inside an outline, so they won't be intersecting. Click OK, and we'll just rename this one. And we'll set that one. And then we'll just add the final reduce element. And this time for the gravel. So we'll select that hatch. There we are. Okay. And I'll just rename it adjust for gravel. And then it will just calculate. And there we are. We have our finished floor levels and our adjustments for each of the types of surface. When adjusting areas to subgrade, the element colours display is incredibly helpful. You can find it here, and it shades each element with a colour which you can adjust according to the plan. This just makes it much easier to understand what areas are being modified. It is a good idea though to verify the elevations either by using your mouse cursor, so you can see the total cut, but you can also see the ground level and the proposed level, so just make sure that they kind of match what you expect. And then we can also add a cross section. Double click on measurements, click cross section, and then perhaps just going straight across so we can see all 3 areas of adjustment. Finish, done. Okay, and we can view that here, and there we can see you can double check that that cross section is correct. The ground level is the green line and the proposed surface is the pink line. So that's all the calculations complete for this project, but we can do one last thing to add context to your project, and that's to overlay a satellite image. So if we go to Plans and Add Image File, okay, so we've got our satellite image here, and we've got two known locational points, so we can align our site plan to our project. So we'll do this one here first. So 324.850, 680.750. Okay, and then we just move to the second point down here. Make that one 6. Oh, Hastings is 323.980 and 680.150 for the north. Okay, so after aligning the image, you can see it's obscuring the project. So we can place it beneath the proposed model and line work in the layer stack by moving it down the list in the plans menu. So we've got the two plans here. We've got the site plan and the satellite image. So just by moving it down with this option, you can see that the site plan is now over the top. Maybe easier to see in 3D, actually. We can see that the site plan is now over the top of the satellite image, but we still can't see that cut and fill. It's just showing the kind of the terrain. So we can move it down again. And this time you can see that now it's giving the context of the location with our road and this kind of hilly area. And then we've got our proposed cut and fill. And you can still see the site plan over the top of that. So this, when seen in 3D, it does give you a clear visual context of the site, showing the existing terrain, the proposed cut and fill, and site plan and the surrounding area. It may be that your site plan would exceed the existing and proposed area, so that would give additional context as well. With the project complete, we can now export the data. Kubla Cubed offers various export options. So estimation exports let you generate a detailed estimation report either as a Word document or as a spreadsheet, which includes a breakdown of the cut and fill volumes, surface areas and other relevant data. And then the drawing exports give you finalised drawings as PDF, CAD and image formats. And additional exports let you generate contour lines or gridded data and more, as you can see, depending on the needs of your project. These exports allow you to share precise project details with clients, contractors or stakeholders. So I hope they are of use to you. Thank you for watching, and if you have any questions, please leave them in the comments below or visit our forums for further discussion.